This video will talk about how to use combinations and what they are. It's another very important function in math. But first, let's look at the problem. How many integers between 2020 and 2400 have 4 distinct digits arranged in increasing order? So our conditions here is that the number has to be between 2020 and 2400. It has to have 4 distinct digits. It has to be arranged in increasing order. And these are our options. So what I like to do when given a problem like this is just give ourselves 4 different dashes to write down integers for our 4-digit number. And now I just like to decide which integers are certain, meaning they only have one possibility. So immediately I see that the thousands place only has one possible integer. That's 2, because the number has to be between 2020 and 2400. So that means the thousands place has to be 2. And if I look a bit closer, I can see that the hundreds place also only has one possibility. Since the integers, this integer here has to be greater than 2 because it needs to be arranged in increasing order, and it needs to be less than 2400. So it has to be between 2 and this 4 here. So the only number that satisfies that is 3. Now, this is where combinations come in when deciding how many ways we can fill in these 2 digits. So first, let's go over what combinations are. So a combination asks one question. So let's see with an example. Let's take a combination 4 choose 2. So that's how a combination is read. We just say the top number, then we say choose, and then the bottom number, and this is how it's written. We use these big parentheses like curves from the top number to the bottom number. So a combination like this asks one question. It asks, in how many different ways can I choose sets of 2 from a total of 4? So to demonstrate that, I have 4 balls here. So in how many ways can I choose 2 different, can I choose sets of 2? So I could choose a red and a blue. That's a set of 2. So I could choose a red and a blue, or I could choose an orange and a green, or I could choose an orange and a blue, or I could do a red and an orange. And turns out in this way, if we figured out all the different sets of 2 we can make from this 4, there are 6 different sets. So there are only 6 because we can't count red and blue and red as the same set, because they're the same set. In a set, the order doesn't matter. We're only looking at what's there, not its order. So that means there are 6 only. No repeats of the same 2 sets in different orders. That's a set. In a set, an order of the things inside it doesn't really matter. So here, let's see how combinations apply. So we have so now let's first decide what numbers we could fill in here. Right, so we have any number that's greater than 3, so any digit that's greater than 3. So that would be 4, 5, 6, 7, 8, and 9. So that means we have 6 different integers that we could fill in here. What we could do is just choose 2 from here and arrange them in increasing order, and then fill it out. Fill it in these two places. That would work. So that means our combination is a total of 6, and from 6 we're seeing how many ways we can choose sets of 2. So that would mean it's 6, choose 2. And it's written like this. So how do we compute this? So 4 choose 2 is 6. But how do we compute 6 choose 2? So for that, we actually have a formula. So if a combination's in the form n choose r, then we use n factorial over r factorial times n minus r factorial. This formula works for any combination. You just have to fill in the numbers. We just have to substitute n and r from our combination. So our combination is 6 choose 2, so substitute 6 for n and 2 for r, and we could solve this and then get the answer, but this also looks like it's going to take some work. There is a shortcut to this, though, for smaller combinations. So if we have, usually the way we compute combinations is with this shortcut way. So let's see how it's done. So we take the bottom number, which is 2. In this case, it's 2. So we take the top. So we take the first 2 factors from 6 factorial. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. The first 2 factors from 6 factorial are 6 and 5. And in the denominator, we just write the bottom number factorial. So in this case, it's 2 factorial. And then we compute this. If the bottom number was anything other than 2, then if it was 6 choose 3, for example, we would take the first 3 factors from 6 factorial. So that would be 6, 5, and 4. And if it was 4, we would take the first 4 factors from 6 factorial. So that would be 6, 5, 4, and 3. So in this case, it's only 2, so we take the first 2 factors from 6 factorial, which is 6 and 5. Now, if we can compute this, so 6 times 5 is 30, divided by 2 factorial, that's 30 divided by 2, which is 15. So there are 15 different ways we can choose 2 numbers from these 6 integers and then arrange them in increasing order over here. So that means our answer is 15, which is option C.